Thanks for joining. Today is day one, and today is basically our introductory session. So today I'm going to explain you that how we are going to proceed in this particular training. We have CCNA routing and switching first, then we'll go to BGP. Then we have the automation. So we'll start with Python and then CCNA DevNet. So that learning agenda will be starting with CCNA, and then we'll go to BGP. This will be little bit advanced training. Then we'll go to Python. And then finally, we have CCNA DevNet. Okay, so I'm going to follow this particular pattern or these agendas one by one. Okay. If you have any query, you can ask on this. It's okay to go like this, or you want to change this plan.
Yeah, that's right.
You're okay with it? Okay. All right. So what we need here, I will give you the link where I will upload all these recorded session. And then the document that you are seeing here, this document link as well. So I have those link. I will, let me ping you in the chat window. And from your side, you can check that you are able to access or not. All right, so far we have discussed about how you can go and perform the lab, the document link and other links. As time progresses, I will share you all those links. If it is there, I will go and share you all those links and the lab as well. If some portion of the lab we are unable to do in our lab setup, but that is not true. You can perform all the tasks in that lab session. But in case if some small things are there that we are unable to do in our lab setup, in Eve lab setup, then in those cases, I will give you the cloud hosted lab access as well, where you can practice that. Okay. And let me know in case you don't have resources to start the lab in your laptop, in your workstation, then I will give you cloud hosted labs as well. So those options I have. All right. So let's start. CCNA 1.1. And I'm going to tell you one good news about first of all, the training is okay. You will learn the basics and then you will learn the automation. Automation is something that every network engineer should learn because that's the future. And you know that automation is also nowadays, it's little bit old, you can say old. Why? Because Cisco has done their Cisco Live 2-3 days back, and they have announced about actually that is CCDE in AI. So you know that the future where we are moving is the artificial intelligence, AI, right? And they are going to announce this on 9th of June. So they are going to release the exam for CCDE in AI, design expert in artificial intelligence, uh, in this date. But what they will do, you will see that in this CCNA syllabus that we have, at the moment, we don't have any AI topic, but one of the module you will see maybe 7.0, maybe after 5-6 months, they will go and add one module related to AI. I'm going to start this course. Actually, course means I have courses in Udemy. So for Udemy, I'm going to start the training course for CCDE in AI. Maybe after next month or 2-3 months, I will share you the link. Parallelly, you can watch those videos as well. You know, if you have time, just 15-20 minutes, you can go and watch. Why? Because how we are going to use AI in network. So those things will be covered then. Machine learning, AI, use of AI and all those things. And whenever I make my content, Like, these contents. Okay, this is the Cisco syllabus, but content that I will show you or we are going to learn is purely my content. So I am developing my own content. I'm not copying from any other resources and here and there. I'm working on that. I'm developing my own content. So this content also I will develop related to AI, since these are the new things. And if you know these things coming to the market before others knowing these things, so you have the upper hand. And even you can think little bit more that, okay, AI, how I can use in network. Okay, which tools are there? Which Cisco tools are there? Which is capable understanding AI and all. Nowadays, DNA, we have machine learning capabilities. In Cisco DNA, we have AI options, right? In iOS XE, if you integrate with some other tools, they have these AI and machine learning capabilities. The wireless network, they have AI capabilities. So behind this, in these tools, they have the artificial intelligence capability. But in real life, what will be the real life use or what will be the business use? That we can understand once we explore these things, right? But anyways, why I tell you this story, because this is the future. Maybe after 6 months or 8 months or 1 year, you have to move in this direction as well, and you have to look this option as well. And the prerequisite for AI also will be your network fundamentals and programming. So if you know programming, then you can do something related to code related things in these tools, right? All right, so let's start the training. This is day one, and this is very much introductory session. So that's why I don't have much to cover today. But if you have access to this document, and if you go through this document, in these documents, I have clearly mentioned day one. And day one, what we are going to discuss today, you can see, if you see the Cisco syllabus, you will find that 1.1. So they have this 6 module in CCNA. This is something that we can skip, automation and programmability. Why? Because anyways, we are going to learn CCNA DevNet. So this thing will be automatically covered in that. But these are the 5 topics that we can learn. Now in these 5 topics, this is very much theoretical thing, like what are different type of security options we have and all those things. In terms of lab and understanding those topics, we have these 4 major topics: network fundamental, network access, IP connectivity, IP services, security fundamentals. Right? You can see the weightage as well. Now, if you go to section 1, network fundamentals, you will see that within section 1, you have so many subsections. I haven't added these subsections, but you may have 1.1 up to 1.2, 1.3, 1.4, 1.5, 1.7, 1.8, like that. And in all those subsections, you have again subsections within subsections, like 1.1a, b, c, d, e, like that. Right. So let's start with 1.1, network fundamentals. We have to understand the rules and functions of network component. Right. Now, before going to these topics, if you are very new to network, maybe you don't know what is router, what is layer 2, layer 3 switches, firewalls, and all those things. These are the components which is used in a network to provide some services, but you are using these devices. Who is using these devices? What are the parties who is using these network devices?
The network team and users.
Yeah, users, yeah, right. Users, okay. Users. Let me change the color. Let me change this to white. If it, okay, yellow. Not good. Red. This color seems okay. Users will go and use the networking component. But if you check this, in your network, you will find these 3 things. Obviously, in your network, you have network components. Why this is important, I'll tell you. Then you have clients, and you have now any network. Think about any type of network. Do you have anything more than these three components? Networking components, clients, and application. Apart from this, do you have any other thing in network? Or any other thing that is influenced by network? Clients or user, they
Mm,
are same thing. Yeah.
the firewalls, load balancers.
Firewall, load balancers, they are part of network, right? Network component.
Mhm.
Networking or networking devices. So components means these things.
Mhm.
Then
That's it.
who is using your network? Some client. And what they are using in the network? Application, right? Three parts we have in a network. Like not in a network, but you can say this IT infrastructure. In your IT infrastructure, you have three parts: networking components, client, okay, applications, right? Now, before coming to these things, I just wanted to show you one diagram. So let me go to diagram here. One big diagram if I have. Should have one big diagram. Oh, here you can see. This is one of the diagram, for example. And you can see all these devices. Again, I'll go and explain these things. This is part of day 2, but I just wanted to show you the diagram. Now let me go and come here. This, even you can think about this diagram. So core, distribution, aggregation, access, etc., etc. But you'll see that you have your IT infrastructure where you have these devices, right? So user will come and it will get connected to the devices. So user will come. So suppose I have one user. This user will come and it will get connect to devices, right? So one component is that the client or users. The second component, you have the full IT networking components, devices, leaf, spine, firewall, load balancer, and all those things. And then the user, when it will get connected to this network, what it will use. So somewhere in this location, you have server, right? Somewhere you have server, and on those servers, you have some applications, right? So user will go and use those applications. So three components are there. In network, you have three components. One is the user you're telling the client. Second one may be your IT infrastructure. And third one, you have the applications, right? So now we have to understand that, okay, when you're using these IT infrastructure, what are the components you have, right? We have to understand and we have to segregate those components slowly, we'll understand this. So if you go and check the syllabus, day 1.1, routers, layer 3, layer 2 switches, firewall, access point, and all those things will be there, right? Let's just start with a router. What is the use of router? What's the use of router?
Is where we define the where the traffic will go, what will connect with what, etc. All the the policies, the routing policies are defined.
Okay. Yes, you're 100% right. 100% right, correct. Suppose if aliens has to come to this world Earth, how they will come? They will use some
So
sort
you,
of, yeah, they will use some sort of gateway, right? Gateway, some gate
yep,
from where they can enter.
exactly.
So router is like that. Yeah, you're 100% right. Router is like this. That is a type of gateway device from where someone can move out from internal network to outside, or from outside to inside someone can come. So here you can see LAN is nothing but local area network. So someone can come to LAN, or from LAN someone can move out to the outside world, maybe WAN or internet. So router is working as a gateway device, right? It is a gateway. So technically it will go and stop the broadcast. Routers, they are stopping the broadcast, and then routers, on basis of routing protocols, they will build the best path, and then they will suggest you. So to reach to that destination, you have this path, this path, this path. Although I have these three paths, but I will suggest you this is the best path. So although you have paths that you can see, but still it will go and suggest you that not only these paths you have, but you have the best path option as well. So I have these two paths as a backup, but I can give you best path as well. If you use that best path, your latency will be low, you will reach within time, the traffic is less, and all those things, right? That's the responsibility of a router, to stop the broadcast, and then on basis of routing protocols, it will provide you the best path. Okay. Obviously, you will go and do so many configurations on router. We will check those things. You understood this router? One very interesting thing about router is this, that whenever you have router, and we are going to discuss this later on as well. So suppose this is one of my router, and in these routers, you have interfaces. You have interfaces. We will discuss about interfaces as well, like gigabit Ethernet or fast Ethernet, etc. Point here is this, that since these routers, they are stopping the broadcast domain. So that means that whatever link that these routers they have, whatever arms these routers they have, they are separate network. So this network is suppose different. And now again, we are going to discuss about the network and the host in the same. What is network, what is host? We are going to discuss about that later on. But the point here is this, that they are part of different network. So you can see 1.0, 2.0, 3.0, right? And these interfaces that you are seeing, obviously the IP address over the interface will be some fixed value. We'll discuss about that. But these network portions that you are seeing, these are this router connected network. They are connected. Later on, these routers can learn some floating values as well. Some other network, someone can tell, okay, learn my 5.0 and install in your memory. So they can learn some other network as well, that we will discuss later on. But routers, all interfaces, whatever interfaces they have, they are part of different network, because they are stopping the broadcast domain. Now, suppose if this router is connected with one of the switch, and the switch that you are seeing here in the bottom, suppose this link having network 10.1.2.0/24, and this WAN router, this is point-to-point link, assume, suppose 10.2.2.0/30. Again, we'll discuss about this 30 and 24 and all those things. So point here is this: when router will go and connect with switch, the switch, they are part of same broadcast domain. So within switch, so suppose if I have one switch, assume that I have one switch here, and then with the switch, what you will connect? With the switch, you will go and connect the end devices, like any type of devices. In networking, we are telling them as a terminating devices. Terminating devices means where your network will get stopped. So suppose if I go and connect IPTV with this switch, so my network will go and stop there. If I go and connect some laptop or some desktop with these interfaces, my network will stop there. So those are terminating devices. These switches, they are connected with terminating devices, IPTV, laptop, desktop, some biometric devices, etc., etc. So these devices that we have in the bottom, they have some fixed addresses, right? They have some fixed addresses. So suppose, for example, I have one device here, one laptop connected here whose IP is 10.1.2.10, and then the other PC IP 10.1.2.11. So these are the two IPs with this laptop and this laptop. And then you have one switch here. Switch may have some management IP and all, but the point here is this, important point here is this, that if this PC has to communicate with this PC, that communication will be local within the switch, right? Within the switch, this communication will happen. But if I have one more switch connected with this router here, and you know that these routers, different ARM having different IP. So suppose this is 10.1.3.0/24. And here you have one more, suppose only one PC connected with this switch. This is a switch. And this PC having IP 10.1. Suppose 3.100. So what we are discussing earlier, that when these devices, they are doing local communication, so they will go cross the switch interface and reach to other side, from one laptop to other laptop. But if they have to go to the different network, so from 2.0, here you have 2.0, if they have to go and reach to 3.0, then these requests, this is called as a ANDing process, means they will try to send packets within the network. Since the destination is outside the network, then the router will work as a gateway device, and then a router will give the path that how to reach to the 3.100 network. How to reach here, router will go and give the instruction, because now you are in different network. You are in 2 network and you want to reach into 3 network. Since the routers, they are in different broadcast domain, so you can move from 2 to 3. That's the use we have with the routers. You understood this concept? Is okay?
Yes, sir.
All right. So that's the router, use of router. Then layer 2 and layer 3 switch. Layer 3 switch. When we are talking about layer 3 switch, you can think as a switch which has brain. Layer 2 switch, obviously it has brain, but it has limited scope. It can't do routing things. Layer 3 switches, although they are the switches, but they have some intelligence. They can have routing processor in that. So this layer 3 switches, so if I go here and replace this router with layer 3 switch, so still whatever concepts that we have learned, that will be applicable. So this is my layer 2 switch where I have connected the terminating devices, and this layer 2 switch is connected with layer 3 switch where it can go and provide the gateway. So that is one of the use of the layer 3 switch, one of the use, not the entire use of layer 3 switch. When we'll go and learn about the design, when we are designing the network, so over the edge, over the network gateway, we are defining the routers. Routers are there mostly near to the WAN, where you have the WAN network, where you have the internet. Because after internet, you have firewall and then you have router. Then your core router will be connected with core switch, and then your core switch will connected with the core layer 3 distribution switch. We'll check the design we have in the next session in day 2. But that's the hierarchy. So router will connect with the layer 3 switch, layer 3 will connect with layer 2 switch. Layer 3 switch, why? Because you have the endpoints and servers connected with the layer 2 switches, right? And here you can see that layer 3 switch we are connecting with the access point as well. So this is the design architecture we have that we are going to discuss more in the day 2 training as well, where we have little bit complicated architecture and we'll understand that architecture. But at this point of time, your layer 2 devices, layer 2 switches, they are working as an access switch. You want to aggregate your switches. So suppose you have 100 access switch. Those 100 access switches can be connected with 2 or 3 aggregation switch, right? And then that aggregation switch can connected or terminated with routers or access point. So that's the use we have with the layer 2 and layer 3 switches. Any question on this? So, okay. Yeah, you will understand more as we move along. You'll understand. Was the use of next generation firewall and IPS IDS? It's a big topic. We have separate IPS and firewall trainings and all. At the moment, if any traffic that is coming from outside, maybe this is interconnect switch, IC switches that we are deploying in the data centers, they may be connected with DDoS appliances. So when external traffic is hitting, they are hitting to the DDoS and then interconnect switch and then the perimeter firewalls, and then it is coming to routers, then layer 3 switches, then layer 2 switches, basically layer 3 switches and leaf spine structure, and then you have the servers, right? So again, we'll discuss about that architecture in upcoming session, but that's the flow. You don't want to trust outside network. So what you will do, you will go and implement the firewalls, the IPS IDS sensors. So you can filter those traffic before coming to the inside of your perimeter, inside of your network. So that's why we are using the next generation firewall IPS IDS, although both are different. Next generation firewall function is different. IPS, intrusion prevention system, IDS, intrusion detection system, those functions are different, but they are the security walls, they are the security appliances that we are using to secure the network, right? Then 1.d, we have to understand the placement of the access point. See, two things are there. Access point. Access points, they are used in the wireless network and access point. Since they are in the wireless network, so the devices that will go and connect with these access point, these devices also should have a wireless adapter, a wireless NIC card, right? So these access points, they are, you can think that they are broadcasting some network. That network is nothing but SSID. SSID. So they have some network, and then these laptops, they are working as a receiver. So we can think that these access point, they are working as a transmitter. So this is one transmitter, and then your laptop, your maybe your mobile phones, they are working as a receiver, that they can receive that particular network. And then as per the pre-configured username password, you can, once you connect to those network, they will ask you what's the username password. You can give the username and password, and you can join that network. The important line here is this, the important factor here is this, that all this wireless network, all this wireless network, they somewhere they have the wired backbone. So somewhere they are also connected with wire. See, obviously they have to connect somewhere with the cables as well. So that's why they have some 4 or 5 interfaces that they can go and connect with the switches. But these access points that you are seeing, they do not have much brain. These access point need controllers. And that's why we have one concept called WLC, wireless LAN controllers. We are connecting these devices with the, so here I'm not showing, somewhere I think I have shown the controllers, but anyways, no problem. We are connecting these switches with the controllers as well. Actually here it should be WLC, and in the layer 2 switch you have APs, access point. Anyways, in the design section we can explore more on that. You can see controller switch and all. So these access points, they do not have much brain, and they need configuration. They need all the prerequisites that is coming from the WLC. So here you can see in this diagram that the brain is nothing but the controllers, and these controllers, they can connect with the switch. Obviously the APs, somehow they have to reach to the AP. You know the concept here, that these controllers geographically they can be anywhere, and APs can be anywhere. What they need some sort of management connectivity. Somehow the AP should reach to controller. In between, there is no condition where the controller lives, where the AP lives. So you may have 5,000 access points at 200 different places, and you may have controller at data center. From that particular controller, you can manage all the APs, all the configuration, profiles, and again, there are a lot in that world as well, in the wireless network as well. But as a CCNA practitioner, yeah, you have the controllers and APs, and that is their connectivity. Then endpoints, the terminating devices. So we know that we have the DDoS appliances, interconnect switches. Let me write here. Suppose, let me write in the sequence. So internet, right? Internet, and then DDoS appliances, then interconnect switch, IC switches, and then it is connected with, then you have the routers, right? Then you have the routers, and then you have switch, then you have endpoint. With this switch, you may have users and servers. Again, here you have bigger story. Bigger story here. Entire data center fabric is here in this, behind the core router or the edge router, right? So likewise, you have the endpoint machines, and it can be anything. It can be some biometric devices. It can be printer, it can be any of the laptop, desktop, and anything, right? So long story about this endpoint devices as well, but it is connected with the layer 2 switch or access switch. Servers, why we need servers? Because all the users, if you see the last diagram, and let me try to revert back the diagram. So if you see this diagram, where is the user? You have the users. Users, they are connected with some AnyConnect or VPN, and they are coming maybe from internet, or maybe it can come via WAN as well, wide area network. That is different type of backbone. So users, they are coming like this, and where you have your applications are hosted over the server. So they can go and use the application hosted over servers, right? So users, they are coming from outside, they can use the application hosted over server. That's why we have the servers, and that's why we have the client server relationship. Servers are nothing but hosting some applications over the Dockers, over the VMware infrastructure. They may they may have physical infrastructure, any type of servers, maybe the servers or the application precisely. Applications may be hosted over the Dockers containers, may be hosted over physical server, may be hosted over virtual servers, may be hosted in the cloud. Anywhere your applications live, anywhere in the world that you want to reach. And then we have the PoE, power over Ethernet. So when you are connecting the IP phones, right? IP phones, so you have the PoE switch, means the switch itself will provide the power to the devices. So you can go and connect the IP phones to the switch, to those interfaces where you can go and enable the PoE. Then these devices will get power from those interfaces and they will work. So these PoE devices also part of the endpoints only. Servers are also type of endpoint. Endpoint may be anything. Servers, PoE devices, biometric devices, printers, all those things. Great. So we have completed day one. Day one was basically the introduction of how we are going to get the resources and the lab infra and all those things, and the basics of network components. If you have any question, please feel free to ask. Thanks for joining. Day number two, we have to learn about different type of network topologies. Now, these topologies that we are going to study, you can see 1.2 A, B, C, D up to F. This is in terms of CCNA. Again, these topologies you have in terms of in terms of CCNP and CCIE design part as well. But as a network associate engineer, how you are looking these type of skeletons, these type of topologies, and what are the things you will take out from that. That's the topic we have to understand different type of network topologies within the network. Now, earlier, if you check, so different books are there related to CCNA, like ICND1, ICND2, or older CCNA book. Earlier, you know that CCNA having different type of parts itself. Earlier, we have CCNA in routing switching, CCNA in security, CCNA in voice, CCNA, like whatever networking streams we have, earlier we have CCNA in that particular area. Now what Cisco has done, they have collapsed all the CCNA into one. So now you don't have CCNA in wires, security, wireless, all those things. Now you have only one CCNA. Once you go and complete this CCNA, then you can choose different path like uh, enterprise, then you can choose security or wireless or ISP, etc. Like that. Different categories are there, but CCNA is one nowadays. Only CCNA DevNet is the other thing, but CCNA, so this particular course that we have is one CCNA for all the different tracks. Now that's the reason if you go and check the syllabus, you will see that Cisco has added most of the things that is related. So here you can see that related to security. Now this is something like taken from CCNA security. Then you can see IP connectivity and IP services. IP connectivity, at least this is very much related to CCNA ISP. Then normal CCNA topics. Even this CCNA that we are studying, then if you study encor, CCNP encor, then that will be the prerequisite for CCI enterprise and CCI wireless. So you will see that in these topics, you have little bit of wireless as well. APs and wireless and antennas and all those things. So this particular CCNA is mix of different type of technologies. And then Cisco is expecting that we should know little bit of design as well, because once you go work in any of the company, you will get some network topology. From that network topology, you need to figure out what's the topology for data center, what's the topology for branches, what's the topology for headquarters and all. And from that topology, you have to go and do some operational task or some troubleshooting, right? So let's understand these different type of architectures that we have: 2-tier, 3-tier, leaf spine WAN, small offices, home offices, on-prem. Now, before going to this particular topology, if I go and list out means that when you're working, you have servers somewhere. So that will be your data center, right? Then you may have headquarters, like not the offices, not big like data centers, but they are big offices. They are the main branches, headquarters. So in headquarters also you may have servers or other application. And then you have branches. Nowadays, and these branches may be small. Again, you can categorize the branches: small, medium, and you may have big branches. So these branches that you are seeing, if these branches are very big, they will go and touch the headquarter type of infra, HQ type of infra. And then nowadays we have something called infra as a service branch as well. Like those type of branches, they are directly connected with cloud. And nowadays the network is so complex that you can't imagine that you have one infra, you have one IT infra, you have one network, and it is not connected with cloud, or your infra is not using any cloud resources. So you should have some cloud connectivity as well. So according to these parameters, we can go and further subdivide the network architecture. So if it is a data center, you should follow leaf spine structure. And if it is a branch or HQ, then it will go and follow 2-tier or 3-tier architecture. Why we have 2-tier, 3-tier, we'll discuss about that. Obviously, either it's a data center, HQ or branch, you want to go outside and utilize the resources outside, or from someone from outside wants to come inside and use your resources. So in that case, you should have the WAN, the concept of WAN, wide area network. So irrespective of what branches and data center we have, we should have connectivity with the WAN. Then you can see a small office, home office. This is nothing but the branches, right? So likewise, we have the category. We have data center, we have branches, we have HQ, we have infra as a service. That will go and fit the entire IT infrastructure. So let's understand this one by one. It's a 2-tier architecture. 2-tier architecture means that you are directly connected. So let me show you the diagram here for 2-tier architecture. In 2-tier architecture, you are directly connected. So here you can see that you have access switch, and then you have the distribution core. So you have, this is termed as a collapsed core. Sometimes it is referred as a collapsed core. That means your access switches are directly connected to the core switches or core of the network. If we go and check the diagram for three-tier architecture, you will see that you have your access, you have your distribution, and then you have the core switches, right? So see, the point here is this, that the connectivity, no problem. Even I can go to access switch, and that access switch, I can make this as a distribution switch, as access slash distribution slash core. And then directly this access switch will go and connect with the core router and then the WAN. In terms of connectivity, we don't have any issue. Any switch can do anything. I can use layer 3 switch, and that switch can connect to the internet. So there is no problem on that. So point here is this. The important point here is this, related to these architecture, is the isolation. That's the important factor we have. We want to isolate. We want to isolate, or we want to categorize. We want to give different resources for different purpose. If we understand that part, okay, you have different type of devices solving different type of purpose, then that is okay. So in that area, we will be good in terms of designing. So here, if you see this diagram, in this diagram, you can see that you have access switch. Access switch will be 2950 or maybe 3850, those type of switches, which are little bit cheaper, but they should be secure as well. Cheaper doesn't mean that we'll go and compromise with the security. So those switches are little bit on lower side, but they have good amount of port density. So for example, in terms of devices, suppose I have 3850 switch having 48 ports, and they are connected with the servers or maybe devices, means maybe PC. Okay, so you have these switches working as a access switch. Now, here's the problem. These access switch, suppose if I have 10 switch, for example, so, and one switch, one interface is 1 gig of speed. So you have 48 switches. So what will be overall throughput? 480 gig, right? 480 gig. So that means that if devices are connected, so if devices are connected here, this here, assume that we have 48 switches, oh, 10 switches, sorry. We have 10 switches, and one switch is connected with 48 ports. And one of the interface, so whatever interfaces we have, the interface speed is 1 gig. Suppose this is 1 gig link, right? So what will be the overall 10 switches into 48 ports? That means 480 gig. The bandwidth requirement that you have at this point, that will be 480 gig, right? Do you know any switch whose interface speed is 480 gig? No, right? There is no switch whose interface speed is 480 gig. So that means that we have some issue here, that the speed consistency in between speed in between the access switch. Assume that here you have 10 access switch need to get aggregated to one, for example, one distribution switch, right? And the bandwidth requirement that you have in between, in between these switches, the pipe that you want here, Suppose assume that this is the pipe. Let me go and draw it one more time. It's 4 gig. Huge bandwidth requirement is there. That's why in upcoming sessions you will come to know that we are bundling these ports. We are taking 2, 4, 8, 16 interfaces in a bundle, and we are creating the aggregation. You can see the aggregation here, aggregation in between them. Otherwise, how it is possible? Because the incoming speed is 480. So sending speed is 480, but receiving speed may be 10 gig. Max they have 10 gig of receiving capability. That means that there are packet drops, issues in the network, issues in the overall, you can say the client performance, or the performance related to application, or all those issues will come. Why? Because you have heavy packet drops on this link. Over this link, you will see that packet drops are there. Obviously, it will be there because we are taking example with only 10 switches. In production network, you may have 100 switches. And then 100 switches means that you need 4800 gig of bandwidth in the aggregation layer, right? So the better design is this. What will be the better design? Say this is with a small group of switches. So what you can do here to improve this design, that you can group, you can go and group these number of access switches in a small group. A small group means that this. So now what you can do, if your network is big, you can go and group these access. Let me tell you. You can go and yeah, you can group these access switches, and these access switches you can connect with the distribution switch as an aggregation link. So 10 switches per group or 8 switches per group, right? Like that, you can group these switches. And likewise, you may have other groups, small groups. Maybe you have 10 or 15 groups. Now, once you have 10 or 15 groups, your network is expanding east to west. Now you have 10 to 11 groups where you have group of access switches and distribution switches, but the same problem will arise as earlier. So in this case, suppose if you have 10 distribution switches, right? So what will be the issue related to this particular bandwidth? Here you have the bandwidth issue. Let me clean all this diagram. So same thing, first of all, why you need 3-tier architecture? Because you have more number of access switches that you want to aggregate, right? That you want to aggregate, and this is as per the design. This, we are discussing about design. We'll go and discuss more about these roles as well. But at the moment, we are simply thinking about the bandwidth throughput and the design. So here you can see that now if your access switches will grow, so all the access switches, you will not connect with one or two distribution switch. In that case, you will group the access switches, and then those small groups of access switches will connect with the distribution switch. Obviously, you have the aggregated links here. So here you can see in the diagram that you have the aggregation. You have some ether channel bundling of the ports, etc. So you have the aggregation here, but what will happen if you have more number of distribution switches, so same speed problem will come here. So in that case, again, you can go and bundle these ports to the core switches, and then you need 3-tier architecture. If it is a small network, 2-tier architecture is well and good. If it is a big architecture, you need 3-tier architecture, but still you have problem. Even in this type of design also you have issues. You know what issues you have? Suppose tomorrow if you have to go and add more access switches, right? Then what you will do? Not only you have to go and add more access switches, then you have to go and add the distribution switch as well. Now, if you go and add more access and distribution switch, will you go and add more core switches? Or how you will upgrade the bandwidth? How you will go and upgrade the bandwidth at this layer? It's very difficult, right? How you can go and upgrade the links, the bandwidth, the core switches at the core layer, because this is something that you don't want to change. Say here you can do any changes. So now you can see that in terms of changes, you can think this principle. In terms of changes, here you can do any change, no problem. Again, to do changes at distribution layer, you have some problem. Why? Because this distribution switch, 10 different access switches are dependent on this distribution switch. So if you do any changes here, there will be impact to all those access switches. Now, what about core layer? All the access switches has dependency to core layer. All the distribution layer switches has dependency to core layer. If you do any changes there at core layer, then you have to think about distribution and you have to think about access switches, means overall business may get impacted. So if it is a full-fledged running system, it's very difficult to do the changes and to overcome from layer 2 architecture, layer 3 architecture. Now, actually no one is using nowadays such type of architecture, at least in data center. Now we are in the leaf spine architecture. So if we are talking about big branches, or if we are talking about HQs, headquarters, or data centers, we are not using 2-tier, 3-tier architectures nowadays in data center. They are still good and fine in HQ, in branches, the small branches, it depends. You know that your number of users will not increase. You know that your access switches will not go more than 10, more than 15, 20, or maybe 100, right? So if you are designing a small branches, you can go and use this access switch distribution core switch. If you have little bit big branch, then you can go and uh, create your network like 3-tier architecture. There is no problem, 2-tier and 3-tier. But if you are talking about data center, if you are talking about big branches, then you can go and use the leaf spine architecture. Leaf spine architecture, you will see that you have a spine. That's the backbone. You have leaf. This is very much 2-tier architecture. This 2-tier architecture is there, but it is in a cloth fabric. So what is happening in this fabric, that adding new switches here in the bottom, like here in the leaf level, even in the spine level, is not a problem. And when we are designing such type of network, then we are taking some estimation, we are doing some prediction as well. So at the moment you have two spine, and suppose this is spine. Suppose if we are using 48 port spine. So let me give you the example. Suppose if we have 48 port spine, right? And the leaf spine structure or the cloth fabric is like this, that all leaves should go and connect to a spine. You can see the connectivity. The connectivity is like this, that all the leaves should go and connect with the spine. There is no connectivity in between a spine to a spine, right? All leaves should go and connect to a spine. Like that, we have the connectivity. So suppose if we have two spine in a fabric or in a cluster, how many leaves they can go and connect? So here you can see that only 2 ports we are using, right? That means if I have 48 leaf, for example, sorry, if I'll go and if I go and grow number of leaf, so suppose if I have one more leaf here and one more leaf here, then how will be the connectivity? This, this, this. So if I add two more leaf, how many interfaces I am adding? Only two, right? So that means that this architecture can go and handle how many leaf switches? 48 leaf. That means further you can expand your network up to 48 leaves. Means 48 into 48. How many connections uh, you may have with these servers? So suppose one leaf having 48 ports, and if you have 48 leaf, this will be the upper limit, right? So 48 into 48 means how many hosts you can connect? 48 into second, 48 into 2300 host, approx 2000. Assume that this is approx 2000, 2K, say 2300 or something for. So these many hosts you can connect. So suppose if you have started your network with only 100 customers, right? With this structure, you can grow 100 hosts to 2000, right? Now suppose if you reach to 2000, now suppose further you have to go and add the leaf switch. So in that case, what you can do, and that will be the further expansion in your business. So what you need to do, you have to go and add one spine 3, and then that spine will go and further connect with all the leaves, but that will be the major change. You are at 200, you're reaching to 2000 hosts. It may take some time, but in case if you have that requirement, what you should do, that you can go and connect one extra spine in the fabric, spine number 3, and then all the interfaces will go and connect here. So in that case, you can go and further expand your leaf. So this is one of the architecture we have that is most popular and widely used nowadays in all the places. So hardly you will see nowadays any modern network which is not using this leaf spine architecture in the data center. You have any query in this? Please feel free to ask.
Yes, I have one. In the case you add another spine there, it has to be like in a topology. You always have to connect to all the leaf you have, or you can
Yes.
have,
Yeah.
and that is for redundancy, or what if I don't do one, or I miss one of the connection to one of the leaf? It will still work, or?
Yeah. So this architecture is actually connected with database as well. So they have some controllers as well. So if you do not connect the ports, for example, I will go and add this link here, and then I will not go and add other links, right? So what will happen, that the endpoint information that we have with respect to this leaf or other leaves, they will not reach to this spine. So if something will happen here, right? If this link will go down, the host connected here, they will not find their gateway with this spine.
Okay, got it. So that is because between leaf they are not connected.
Yes, yeah.
Also.
So it's like very, it's a highly redundant type of a structure where everyone is knowing everything. That's why we have such type of clause architecture. That's such type of fabric. All leaf should connect to all the spines. So whatever connectivity we have below these leaves, below these leaf, whatever endpoints we have, MAC addresses and IP addresses, should be synced in between all the spine. So tomorrow, if anything will happen with the link, with the spine, other spine will take care of those information. So the database that these spines have, the endpoint database that these spines have, they are syncing across because we have the redundant links. Okay.
Yeah, got it.
All right. So what we learned so far that different type of architectures that we have. We have two-tier architecture, three-tier architecture, and leaf spine. Now, irrespective of two-tier, three-tier, leaf spine, we need WAN connectivity as well. WAN connectivity means that these skeleton, you can see we are up to core layer, we are up to core switch. So here you can see that we have core layer. This core layer switch will go and connect with the WAN router or border leaf devices or edge devices, because after that it should go to the internet. So in these designs, in design number 1, you can see core. Design number 2, you can see core. Likewise, in this leaf spine architecture, you can see border leaf. Border leaf is what? Border leaf is your edge router from where you want to go outside or inside. But still with this border leaf, we are connecting one extra router as a WAN router. So let me show you that. So when we are talking about the WAN, I will come to this connectivity. Oh, I don't have the architecture, but what we are doing here, let me go and draw extra layers here. So what we'll do, that we'll go and connect extra devices here, a redundant pair of devices here. Like this will connect to this will connect to this, and this will connect to this, and this will connect to, like redundancy is there. Both the devices connect to both the routers. They will work as a WAN router. And these WAN routers are further connected with they have two connections. Either they are going towards the internet or they are going to the other branches. So your inter-site connectivity, so either internet or intranet. So two connectivities are there. Internet means you are going directly to public cloud. Intranet means that you are going within your own branches or data center to HQ or data center to small offices and all. So further from WAN routers, you have internet connectivity, intranet connectivity, right? And that's the role we have with the WAN, the wide area network. So now you have your data center. Now you have your branches. How you will go and connect within these data centers and branches. So here you can see in the diagram, I have given few examples related to different type of WAN connectivity. So maybe you want to connect two sites directly, like data center and HQ. This is DC, this is HQ. Or you can see here the full mesh architecture related to WAN connectivity. So you have DC1, DC2, but then you have branch 1, branch 2, where you have full mesh connectivity. These are the links. Obviously, over these links, you are running some IPsec tunnel or DMVPN or any type of secure tunnel you have. Or you have data center and then you have branches that like hub and spoke. Now, this is not that simple that it is in the diagram, but it is something like you have this data center, right? This data center, and then you have a small branches. So if I have to go and draw here, let me quickly draw here. So we know that full architecture, how it is, you have leaf spine architecture, right? So suppose I have leaf and then I have a spine. So I have 3 leaf and 2 spine, and then I have border leaf, and then I have the core routers, or the not core but edge routers. So what I want to tell here is this, that you have the, suppose leaf 1, leaf 2, leaf 3, and then you have a spine 1, spine 2, and then you have border leaf 1, border leaf 2, and then you have router 1, router 2. So here you will see that you have the connectivity. You have the connectivity like class architecture here, and then you have the border leaf is also type of leaf, so they also have the class architecture, and then you have the routers connected as a mesh connectivity. So from router to border leaf to this, like this, you have connectivity. So these routers that you have, router 1 and router 2, likewise you have architecture below in the branches. So let me go and draw one of the branch. In the branch, you may have 2-tier architecture or you may have 3-tier architecture. So in branch, you have the access switch, and suppose I have distribution switch, and suppose I have one router. And likewise, I have different type of branches. I have one router. So here the branch network is like this, that you have access switch that is connected with the distribution switch. Distribution switch is connected with the core router. And now here you can see the connectivity in between these core routers, or the edge routers to edge routers. That connectivity is coming under WAN, wide area network. Here you may have IPsec tunnel, DMVPA tunnel, what is it? GRE tunnel, Get VPN, or any type of VPN tunnels you have. But the connectivity in between these, suppose here I have the edge router, these edge routers, that connectivity will be your WAN connectivity. And for these WAN connections that you have, you may have this connectivity as point-to-point link or full mesh or hub and spoke. Again, it depends that what type of connectivity requirements we have. You're able to understand up to this point?
Yes, just on another questions. Speaking of cost saving, what is like the best topology to use? I guess like it is the hub and spoke, right?
Hub and spoke, come again? Hub and spoke, what?
Uh, yeah, speaking only for cost saving, what is like the best topology to use?
In terms of cost, you're telling?
Yeah, cost savings. Yeah.
Okay, that is good question. So if I have one, I should have some slides to, okay, this. I will use to represent something here. And I have my SD-WAN topology. Do I have somewhere? Just a second. Okay, so your question here is this, that we have different type of topology. We have point-to-point link, we have hub and spoke, we have full mesh. Which particular topology we should use in terms of cost? The answer is this, that suppose if you are using SD-WAN, what is happening in that case? So you can see that I have one data center and then I have two branch 1 and branch 2. So these branches, they are connected with the ISP, where we are paying the money. Money that when you are using the ISP resources. So suppose you have your WAN link and you are connecting with AT&T, Verizon, etc. It depends upon the speed of these interfaces. Suppose if you are using 1 gig interface, or your agreement with ISP is for 1 gig, then obviously your payment will be more when you will go and pay 500 Mbps, right? So the cost will come into picture when we have agreement and what type of agreement we have with the ISP, the first thing. Second thing here is about the connectivity. Obviously, if you have mesh connectivity, like full mesh connectivity, your number of links will grow. If your number of links will grow, and if your number of links will grow with ISP, your cost will increase automatically. But point here is this, that in terms of design, how I can understand this. In terms of design, what we are doing, we are doing always, we are doing full connectivity. Full connectivity means that always we try to go with full mesh, full mesh topology. Why? Because this SDN topology, they are irrespective of connectivity. So now we have concept of underlay and overlay. So although my underlay having full mesh, although I have this type of connectivity, all to all, any to any, but it depends upon my policy, the policy that I will go and create. I can go and create policy like point to point, like hub and spoke, like partial mesh, like not using one link versus other link, right? So your connectivity, your underlay connectivity may be 100% any to any, full mesh. But when you go and create the policy, which particular route will be taken by which particular group of customers or applications, so that scenario will 100% get changed. So that means if I have this physical connectivity, with this physical connectivity, I may have 3 different types of traffic flow. I may have full mesh traffic flow, I may have partial, I may have point to point. So your underlay and overlay concept will come into this picture. In terms of cost, the simple answer is this: if you grow the number of link with ISP, your cost will increase. But in terms of designing the solution and separating the critical application to other link and the users to other places, and low applications, or lower critical applications to other links, like low critical applications, I may use internet to reduce my price, or I may go and use internet and internet. I will not use MPLS. I may run my application over internet. It depends upon applications and all, to reduce the prices, right? So again, it depends upon the choice of ISP, the number of links we have with the ISP, the bandwidth agreement with the ISP, the price will increase. But nowadays, the architecture, the underlay may be any to any, but overlay may be different. Same underlay, you may have 10 different type of overlay. You got that point?
Yeah.
All right, so let's go back to the SWAN strategy we have. Let's before this, I think I move. Yeah. So after WAN, as per agenda, we are following the syllabus. So we have a small office, home office. This is not different. A small office, home office design, you can see from the design perspective that you may have wired wireless network. They are connected with the switch. Switch is connected. Means here you have tier 2 architecture. Here you may have tier 3 architecture. It is connected with the routers, and then they are connected with the WAN devices. After that, we have one very important topic here is the cloud connectivity. Cloud connectivity, I have created some videos. So while I was working on my CCIE DevNet course, the first module that Cisco has given, the very first module that Cisco has given in CCIE DevNet is related to cloud architecture and design. So cloud is again a big thing. Big thing is means that cloud. So what they have done, this cloud providers, that they check that what issues you have in a network and application and database. So cloud is not like only network. Very a small portion of network is there in cloud. So I'm talking about any cloud like Amazon, Google, or etc. etc. Not the cloud is nothing but someone else data center or someone else network, right? So they have built their network, like Amazon has built their network to provide some services or to provide services to any of customers. Suppose I am a customer, I want database. So for that database, what I need full-fledged house where I have the servers and storage and cooling and powers and cable, all those things, right? And then I will go and install databases software in my servers and I can use it. But on other hand, if you need some services or database service, MongoDB, SQL, or whatever databases, you can go and simply, create one portal in AWS as a customer and you can request for the services. Like this is nothing but pay as go model. You will pay and you will use the services, right? So in terms of using it first time, in terms of using the applications, cloud are very good. But still, this is someone else's network that you have to go and monitor how much resources you are using, what is the timeline you are using, because 95% of times what we are doing, we are not using cloud resources, but we are paying them because they have different type of parameters that they can bill to the customer. And it's very difficult until unless we'll go and understand their pay model, we will never understand that how they are billing to customers. So those things are very, very interesting. Means in cloud, you don't need to go and learn the routing, switching, and other things, but you should know that how they are billing to the customer. That is one of the hardest things to learn in cloud. Different cloud vendors, they have different type of billing parameters, how they are billing to the customers. Anyways, let's come back to the design part. So on-prem, network, and cloud, and then hybrid. Actually, there are three terms. On-prem means your data center, cloud means someone else's data center, and hybrid means that your data center, you can use your data center for your critical applications, but for few application, you can expand your data center towards the cloud. So hybrid means that your data center and cloud, they have some connectivity via Cloud Express or any type of network. So in short, that's the use we have with the cloud. Now this topic is purely related to design. So let's see the design. What is this design? This is on-prem. I should write here on-prem. So on-prem, you can see that on-prem data center or private cloud. Sometimes it is referred as a private cloud as well. So this is the private cloud we have. So this is the private cloud or on-prem. Sometimes it's written on-prem. So private cloud, you can see the skeleton is straightforward. You have the servers, containers, etc. They are in HA. You have VMwares. You have backbone like class architecture. Then you have the gateway devices and then users. Users, they are coming from outside. Come from outside. Actually, users, they will come from outside. They will go and hit the router, firewall, switches, VMs, cluster, and then the applications. Like that, they will reach. A normal flow diagram I have created here just for design purpose. Then if you have cloud resources, so this is pure on-prem. Like you have pure on-prem, you will see pure cloud architecture. Pure cloud architecture, users may come from anywhere. They will hit the firewall, then the cloud network, and then you have containers, Dockers, containers, serverless functions, means you have your applications. Now to balance the load, you may go use load balancers, you may have the gateways, you may have some other techniques or the automation techniques to balance the load. So that's why in cloud you have auto scaling that you can burst. Cloud will provide you on-demand resources. That's one of the nice feature we have in the cloud, auto scaling. You may have Kubernetes, Docker containers, and their orchestrator is nothing but Kubernetes. Then you may have some automation in between that. The point here is this, that cloud is also the same way that you have your on-prem network. There also you have firewall, routers, switches, and your application is hosting. But that is managed via the cloud provider, and it depends upon what agreements we have with the cloud. Are we using infra as a service, platform as a service? So likewise we have the services from the cloud. It's actually very complex nowadays how we are using the services and how it is, and billing and all those things. But yeah, this is cloud infra. Cloud infra will look like this. But nowadays everyone is using the hybrid topology. Hybrid topology means that although you have your infra, let's say I have my on-prem infra, and then cloud infra is there, but in between on-prem and cloud, I have separation of applications. I have separation of the applications, or I have the separation for different type of services. So some critical applications or services I have in my on-prem infra. The same thing that we can do over the cloud, I can do on-prem as well. The point here is this, that in long term, it's very important point. In long term, on-prem cost will decrease, and in longer term, cloud cost will increase. Cloud solution is actually not there for long-term gain. You need to monitor the resources, how you are using. So if business is growing, and if you have your on-prem infra, that is actually good, because in longer run, if you go and check the cost for 10 years or 15 years, then your cost, on-prem cost will obviously decrease, because the cloud, someone else resource you are using, and they will go and change the billing cycles and all, so you have to check in between them. If it is a small requirement, you can go with the on-prem or cloud, but it depends upon the duration of the requirement. If you have suppose if you have some testing environment, you want to test something, you can test in the cloud, no problem at all. You can go and take the resources for 2 months, 3 months, and do it over the cloud. But once you do all the testing and you want to implement, then you go and implement over on-prem. That will be one of the useful use of the cloud. Or unpredictable applications. You don't know that how business will grow. So then in that case, you can start with very small on-prem infra connected with cloud. And then for 2-3 years, you can see that how business is growing. According to that parallelly, you can go and create your on-prem infra, and then later on you can migrate from cloud. Nowadays, you can see the shift is in different way. People are migrating to cloud. From on-prem, you are migrating to cloud, but the time will come when from cloud, you have to go and migrate to on-prem. So, it's like very strange. Everything, it depends upon cost, that. So you have to go and check the cost benefit in long term and short term. Short-term cost benefits, obviously you have with the cloud. But if you have some long-term goal, then you can check that in long-term budget for 10 years for this application, this will be the application growth and this will be the operating cost. Now over the cloud, this is my application growth and this is the cost and this is the added cost. Like if you go and match, you will see long-term, this will be success rather than this. But if you have unpredictable growth, if you have those applications that is actually not possible that you can go and serve in on-prem, then you can go and check the cloud resources as well. That's why we're telling this like win-win situation. So 80% you can utilize your on-prem, 20% you can utilize cloud. There are certain applications that is 100% running over cloud. It depends upon the businesses as well, like food applications and vehicle transport application like Uber, food applications. Here in India, we have Zomato. Your place, I don't know what food applications are there, but Uber Eats is also there. So those applications that they are actually everywhere in that geography. So they may use cloud. That cloud is very much, useful for them. So it depends upon application as well, that which particular vendor we want to choose. We want to go with cloud, or we want to develop our application on-prem. Okay, so that's the story about the cloud and the infra. So in short, that we have these architecture that we should know as CCNA practitioner, that we have 2-tier, 3-tier spine, WAN, and all those things. If you have any further question, please feel free to ask. Thanks for joining. Today, day number 3. The agenda here is this, that we'll go and learn, understand different type of physical interfaces that we have available in the devices. You have different type of devices, right? You have routers, switches, firewall, load balancers, DDoS devices. Different devices having different type of interfaces. Why they have different type of interfaces? Because they have different types of bandwidth requirement. For example, if we have leaf spine fabric within the data center, so there you need maybe 100 gig of bandwidth, or maybe 400 gig interface you need. Nowadays, we have 400 gig interfaces in the data center to the Nexus switches and other DC switches. So you need very high speed fabric. Obviously, for that, you need high speed interfaces. Now, when you are connecting with routers, they are connected with firewall, there you need 40 gig of speed. So your firewall, your IPS IDS, your DDoS devices, their interfaces should have 40 gig. Means that is a requirement nowadays. They should have 40 gig of throughput. Overall, they should have 240 gig of throughput. That means that you have to go and take these interfaces and you have to bundle it in some ether channel or port channel, right? So likewise, you have the bandwidth requirement, and according to that, we have different type of interfaces and their speeds, right? So those things we are going to discuss. And since you will go and connect different interfaces, so you should know what type of cabling options we have. In CCNA, you can see as per our curriculum, we have to understand about single mode fiber, multi-mode fiber, and copper connectivity. Then you can see connection type. We have Ethernet, shared media, and point-to-point. In terms of networking, when you go and connect two devices back to back, like one router to other router, then that is something point-to-point network. But suppose if we have a switch, and that switch you are connecting with two different switches, then this is something like Ethernet shared connectivity. One switch is connected with multiple switches. Yeah, or you can see point to multi-point type of connectivity as well. So single to single device connectivity, point to point. But if you have single to multiple device connectivity, obviously that is point to multi-point, right? So those things we are going to discuss today, and then I will log into the switch and we'll go and check the configuration over the interfaces as well. All right, so let's start with single mode fiber multi-mode. What I have done in this shared document, and that I have created some slides that you will go and read, you will understand. Okay, single mode fiber, the diameter, I should add some diagram as well for single mode fibers and multi-mode fibers. But anyways, that's okay. So you can see the diameter is 8 to 10 microns, which allows only single light mode propagate. I will explain you everything. Everything is documented here. Bandwidth distance, you can see bandwidth distance, they can go up to 100 kilometer. Cost is higher. Use cases suitable for long haul telecommunication network, uh, undersea cables and high speed metro network. So we have two options. We'll not study single mode and multi-mode like they are two isolated modes we have, but rather than, let's go and check this in this chart. So I created a chart, a table here. Now with this table, you will understand that what is single mode, what is multi-mode, when you are using single mode, when you are using multi-mode. First important factor here is this, the distance. So if your network is geographically separated, you can see up to 100 kilometers with single multi-mode fiber, the distance can be 100 kilometer without repeaters, without any what you can see that you can increase the signal strength. So for that, you can use the repeaters. So without any repeaters, you can go up to 100 kilometer. But in case you have to go and connect the devices within a shorter distance, so you can see up to 2 kilometer. For lower speeds, typically 300 to 550 meters for higher speeds. So if your devices are nearby, then you will go and use multi-mode fiber. Why? Because with multi-mode, cost is moderate, right? Cost is moderate. With single mode copper fiber connectivity, your cost is higher, right? Then you can see the copper is also there in a list, copper twisted pair connectivity. So they will give you speed up to 10 Gbps. You can see the bandwidth and distance and even the cost. These are the important factor. So bandwidth with multi-mode, you will get up to 10 Gbps. Here you will get up to 100 Tbps. See, the single mode is actually very fast, and you can see light source is laser, here light source is LED or VCSEL. So point here is this, that okay, we can go and use this fiber mode. Single mode we are using for longer distance, multi-mode we are using for shorter distance, and we have copper connectivity as well. Nowadays, all the devices, they can understand, they can listen fiber. So if you go and see the transceiver, so what is happening, that the switches you have, these switches you are connecting, there are some interface, right, in which you are connecting the cable. So nowadays the interfaces that we have, the 9K series switches, the Nexus switches, there these interfaces, once you purchase the box from Cisco, they will give you a switch. They will actually give you empty switch. Then you have to go and add the power slots, the uh, fan modules and all those things. Apart from that, the interfaces will be empty. You will see that interfaces will not available there. So in that interfaces, you have to insert transceiver. You have to insert one module called transceiver, and that transceiver again you are connecting with 10 gig of multi-mode fiber cables. Right? Even you can see the lights as well on those cables. So it's like that. Its connectivity is like that. So two types of connectivity we have. One connectivity we have that when we have the fiber mode, and one connectivity we have when we have the twisted pair of copper. So two different type of connectivity we have. One connectivity you have even in your laptops, you can see that you have option to connect with RJ45. The cables, like suppose if you have internet at your home, you may have a small routers. There also you will see that now we have options. So nowadays, say in my case, I am using internet, and in my internet connectivity, I have fiber. I am using fiber mode internet. So in my router, the ISP, they are terminating this type of connectivity, LC, SC, ST type of connectivity. LC, LC, they are telling LC, LC connectivity. So in my case, my small router, although that is some maybe China made router they have put in my room, and there that router is very strong. From last 2 years, nothing is happening to that particular small, that is type of router plus access point. So wireless router antenna, and in that they have inserted this LC connectivity. But in that particular router, I have 4 interfaces as well. So that router is coming with 4 different interfaces. So if I can draw here, so in my home, I have one small router, and that router is wireless antenna actually. It has wireless antenna. And in that particular router, the ISP connectivity that is coming from outside to my router is some sort of LC. But in this router, I have one Ethernet module. There is one module in this router. In that module, I have 4 different interfaces: interface 1, interface 2, interface 3, and interface 4. In these 4 interfaces, I can go and connect my local network. I can go and connect my PCs, my laptop, any other network. Even I have connected my CCTV setup with this CCTV set box with this. So I have connected one laptop, one workstation, then I have one CCTV, and then with this interface, I have connected one other switch that is on other floor in the same building. And that is going to the, maybe I think that is going to the ISP link that I have. And on that floor also, I am getting internet. Then I have connected one television, TV, with that small particular switch. So 4 interfaces are there. I'm using all 4 interfaces. So from one source of internet, I'm splitting my internet to camera, CCTV camera. Then connecting with laptop. Then connecting with one server. And then I have extended this network to other floors. Suppose I'm in 3rd floor, I have extended to 5th floor as well with Cat6 cable. Cat6E cable, that is copper twisted cable. So my network, you can see that is the mix. From ISP, I'm getting the LC connectivity. Obviously, they are using multi-mode fiber. So they have the jump box on top of the floor, like on the rooftop. And from there, they are splitting the network. And from their jump box, they have a small cable that is coming to my floor, 3rd floor, where I have this copper type of fiber type of LC connectivity. And then in that small router plus access point, I have 4 Ethernet module, and this 4 Ethernet module, I'm splitting that internet to different locations, different floors. So now you can see that with a small internet setup that I have at my house, at my home, I can understand all these modes of connectivity and all. So when we are talking about full-fledged enterprise network, how they will utilize the resource, right? How they will go and split their network in the interfaces and all those things. Okay. If you have any question, please feel free to ask.
I'm okay so far.
All right. So let's move on. Now, in terms of networking, so this is in terms of that how you're connecting the cables and on. And we should know these topics, these terms as well, when to use what type of media and all. The next topic we have is interesting. That is Ethernet shared media and point-to-point connectivity. And when we are talking about Ethernet shared media, so there is one protocol which is coming into the picture, CSMA-CD, Carrier Sense Multiple Access Collision Detection. So what does it mean? Let me go to the diagram. So suppose you have this switch, this is switch 110, which is access switch. Now this particular switch, suppose this is connected with different PCs. Now these switches, they have one mechanism to stop the collisions. Stop the collisions means why the collision will happen. We'll discuss about that. Let me try to draw it. Okay. See, you can see. So suppose your switch is connected with 4 different PC1 up to 4. Now, suppose these PCs are communicating to each other, and maybe you have one more PC here, suppose, and they have the communication to each other like that. So we are in a switch network. We are within the same broadcast network. So all these switches, they are part of same network. For example, they are part of 10.1.1.0/24. So one network means they are part of same broadcast network. Broadcast network. They are part of same logical network, right? So within same broadcast network, when the switches are communicating to each other, so what they are doing, they are the communication mode. At the moment, we haven't a study about TCP IP stack, like, physical layer, data link layer, network layer, transport layer. Those layers we haven't discussed. I don't know it is there in agenda or not. But anyways, what is happening that you have physical layer. So if you go and check the TCP IP stack OSI model, right? And you may knowing that OSI model, like, physical layer and then data link layer and then network or internet layer and transport layer, and after that you have so many other layers. But in TCP IP, that is application layer. Anyways, so point here is this, that when you are connecting the interfaces, when you do physical connectivity, that is part of physical layer. That is part of physical layer. So these interfaces that we are connecting, they are part of physical layer. But when you do the communication basis on MAC address, we have this topic actually, the IP addresses, little bit of MAC addresses. Yeah, these topics are there in upcoming sessions. So don't worry, you'll understand this. But when you are communicating within the same broadcast network, you can see same broadcast network, then you will use MAC addresses. So these switches, they will use the MAC address. What is the significance of MAC address? That they are the physical address over the interface. They are the local burnt in address over the interfaces. So they will go and use the MAC address to do the communication. Now, suppose if these PCs are communicating and by any chance, if there is congestion in traffic, by any chance, if the packet will collide to themselves due to high volume of communication, like suppose these somewhere you have server. For example, you assume that here you have server. So suppose this is server and these are the client, and within the same room they are playing some online game, and where you have server and client in the same room, that means the transaction of packets are more. Transaction of packets are more in terms of layer 2. We are telling this as a frame and then packet. Okay, so transaction of frames are more, then there may be collision. Packets may collide to each other because they are using same shared media to communicate, because they are part of same network, right? So in that case, what is happening? So if I go and draw a single line, is representing switch here, and then you have the PCs connected. Oops, PCs connected with this single line. That is nothing but interfaces connected to different switch interfaces. So this is what? This is nothing but your shared media. Even the internet that I am using, the broadband, what ISPs they are doing, they have same type of bandwidth, but they are sharing the bandwidth with different customers. So that is also type of shared internet, shared broadband, right? The public cloud. What is public cloud? Public cloud is there. They have same public cloud, but different customers can use that public cloud. So that means they have some shared resources. So here you can see that we have the shared media, and in shared media, there are chances that collision can occur. So packets can go and collide to each other in the shared media. So what is happening? Because you are sending, receiving the packet in different directions and all. So what is happening in these cases, that switches by default, they are using one algorithm that is termed as a CSMA-CD, collision detection technique. So that means whenever these packets are colliding to each other, whenever they will collide, there is some timer in a switch. So then if collision will happen, right, switch will wait. So they will start some timer. Okay, collision happen, wait for 50 milliseconds till the other traffic will get cleared. And once the traffic will get clear, then they will send the frames. So that's the use of CSMSCD. This is some sort of algorithm which will avoid collision, right? All right. Apart from that, you can see the important points here. Commonly used Ethernet LAN such as Ethernet hub, older Ethernet switch operating to devices on the network can send data to all the other devices, and each devices listen to the network. Yeah, the same thing that I have explained you, that in a shared media, you will send the frame to all the devices and there may be chances of collision. If collision, then they will wait for some time. That is nothing but that is the CSMA-CD protocol. That switches, they are working. There are advantages and disadvantages with shared media. Shared media means obviously the cost will be less. If you're sharing the resources, cost will be lesser. Disadvantage means that they are susceptible for the collisions. So collisions may occur, and then if collision will occur, then performance will obviously decrease. Why? Because switches, they are waiting to media to get cleared, right? So those things are very important. The next point here is point-to-point, very easy, straightforward. Point-to-point network means direct-to-direct connectivity. Commonly, it is used in the WAN links. One router will get connected to other router, dedicated resource. Advantage is this, that you have direct connection, suitable for long distance communication. But disadvantage is this, obviously the cost, and you are not using the shared connectivity. That means that cost will increase. So advantage and disadvantage is there. So what we have discussed in 1.3a, so you can see the topics here. The topic you have here in 1.3a is this, that understanding the different type of media techniques, right? So you have different type of media techniques such as single mode, multi-mode, copper connectivity, twisted pair connectivity. And then you have to understand about the connectivity type. So connectivity type, that means you have the shared media, you have the point-to-point connectivity. If you have any question, any doubt in this, please feel free to ask, because we are going to move to next topic.
I have one only. In the collision detections, how much time does it take to retry to send another transmission
Yeah,
once
so
it detects a collision?
yeah, that's good question. So how much time it will take? And this is not like fixed time. They can change the timing as well. Exact what time is there, I need to check, but I'll write this question and I'll give you the explanation. Maybe today itself by the end of the session. What is the
Okay.
time for that back off timer is there? What's the time? So let me write here. Today by the end of the session, I'll give you the answer. Apart from that, any other query?
Yes.
All right, so we'll check the time. What I'll do some Google once we'll complete the session, and I will show you the algorithm as well. I have done this thing, I think maybe 6, 7 years back. So I'll do it one more time. Okay, now next topic you can see that is again related to networking task, network engineering task. Identify interface, cable issues, collision, errors, mismatch, duplex, speeds, right? What I have done that I have copied that diagram. Let me go and paste here in this slide. And then I'll present. So I copy, let me paste. And we'll verify in our diagram these topics that it is telling that what is the collision. Collision is what means when in shared media collision can happen, right? And then we have the CSMA-CD protocol that will come into the picture, and it will start some timer. So wait till that time. When the traffic is clear, then they can send the frames. Then error. What are errors in network? What is duplex mismatch and speed, and how we can go and set the duplex parameter and the speed parameters, and how we can prevent collision, and all those things we are discussing in this particular section. Let's understand this. So you can see that we have common interface cable issues like collision, errors, duplex mismatch, speed mismatch, right? Collision, as as I explained you that why collision is happening. So collision and errors typically indicated physical layer issue. You know, in the OSI model, the stack, the physical layer issue. It's not that when you have traffic and then collision is happening. There may be chances that you have faulty cables, or maybe the cable that you have, it has some issue, like some hardware issue. Maybe after 10 years, you know that all those cables, they are start decaying. No? Decay factor is there, or they are not proper. Even you can see that faulty cables, incorrect cabling standards, physical issues, some damages and all those things, right? Port damage and all those things. So these are nothing but the errors, physical layer issue. If physical layer issue is there, you can't do any troubleshooting. It's like very difficult to understand the physical behavior. I work for Cisco TAC as well, and we are getting cases that all of a sudden network behavior is, network behavior is something that they can't understand. Means it was working earlier, 5 years back. Since 5 years it is working, same configuration, same setup, everything was working fine. All of a sudden it is not working. So we are doing some, troubleshooting, packet captures, this, blah, and all those things. Then we are telling, okay, change the cable. Okay, change the interface. Okay, it's still not working. Then finally we are telling, okay, reboot your router or switch. So after router switch reboot, the issues, general issues got fixed. Like this was the case, 80% of tickets in TAC we used to solve by reloading, rebooting, cable change, swapping cables and all those things. 80% issue in a network you will find, if it is not recoverable, like issues you are not able to fix, 80% of issues are hardware issues. Okay. Either your device memory is exhausting, CPU is going high, or cable is faulty, router is faulty. Like those things, if you go and list the issues, you will see that 80% issues related to this physical issue, physical damage or other things. And then 20% you have related to software and configurations and other, right? So errors and collision happens due to these factors, right? And how you can go and verify that? So actually there is one single command, show interface, and then the interface and that the interface name. Then you can go and check the collision, input error, CRC, frame errors, overruns, ignores, output errors. That means packet can get ignored as well. So if your interfaces are connected, and you're sending packets from one location to other location using that interface, that doesn't mean that your switch will process or router will process all the packet and send to next router. It doesn't, this is not the case all the time. There may be some packets they are unable to understand, and then they will keep blocking that packet. Sometimes it is happening with some sort of jumbo packets, like, big packets. Sometimes it is happening with some sort of multicast packets that routers or switches, they are not understanding. So routers and switches, they also have to understand that what is the packet, what is there in the packet. Otherwise, you will see that overruns, ignores, output errors, the counters will get increased. So if you have network issue, the first command you can go and check is the show interface and Ethernet, and you can go and check these counters. If CRC error will increase, that means your cable, mostly your cable is faulty. Your optical cable may be some issue. This is purely some physical hardware issue. Then you can go and check the other informations as well. So here you can see that we have one output here. I have pasted the output, but I have route. Let me go to our switch and run this command. So if I go to switch number 110, okay, lab center, show IP interface just to see that what interfaces we have, and then show interface E0/0. Now you can see here protocol is connected. This is the burnt address, MAC address, MTU1500 bandwidth. This bandwidth in kilobit, if you convert this, it will give you 100 Mbps. Then you can see the delay, reliability. Now you can see these loads. Sometimes in your infra, your TX RX load will be differently, like you may have good amount of load. So you can go and check that in case your switch is overloaded or not. Then encapsulation, then keep alive, then duplex. So here you can see that full duplex. This interface is running in full duplex mode. And the media type is RJ45. The speed is auto. It is negotiating the speed with the other devices automatically. So this is very important line. Then flow control, you can see. Now you will see here the queuing, the QoS mechanisms like size, max, stop, flushes, then output queue. Then you will see 5 minutes input and output rate. Here you will see some packets. Then multicast packets. Now these lines here, these 2-3 lines, like zero runs, zero giants means bigger packets, smaller packet, discarded packets. Then input error, CRC. This line is basically for hardware failures. Input error, CRC, frames, overrun, ignore. Right? So like that, if you go and see this output, and in this output, you can see if something is there, that means hardware issue. Something is there, that means my device is not understanding, my route is not, or my switch is not understanding that particular packet, and it is keep dropping that packet. So you can figure out from those inputs. And I have pasted the slide here for your reference. Then what action you can take? If input error or CRC error are non-zero, check the physical cable and replace it, right? Cable type is correct, Cat5 is higher, so you can make sure that you don't have any physical issue. Then the next issue, duplex mismatch. So one side, suppose if you are running half duplex, other side you are running full duplex. So you will see that line protocol is up. You can see full duplex, 1 Gbps, for example. So you can go to the interface and you can make this full duplex or half duplex. So if I go here to my switch, conf t, sorry, conf 0/0, suppose speed. Let's go to the interface and see the duplex. You can see duplex. At the moment, duplex is what? Duplex is full duplex. So if I go and make this half. What does it mean by half duplex and full duplex? Half duplex means that either you will send or you receive. Full duplex means you can send and receive both at a time. That's the full duplex. So assuming what is connected, so should it be neighbor? What is connected with this particular switch? E0/, actually we have connectivity 10, right? So let me quickly go and check. If you see the diagram, actually 10 is connected. This is connected, this 10. I should go and check 10 and other side 12. So let's go there. Let's go and check. Do show run interface E1/0, which is actually connected. Do show. The interface may be down. I need to fix the interface as well. E1/0. So here, auto speed, auto duplex. And let me open one more. Show run interface E1/2. Show run interface. Show interface E1/2, right? So this interface is connected. If you see the diagram, 1/2, E1/2. So E1/2 is connected with that particular switch. So if I go to this interface E1/2 and make this duplex as half, so that means that one side I have full duplex, other side I have half duplex. That means we have the duplex mismatch. Logging, okay, logging console. I just wanted to see all the errors on the screen so I can use this command, logging console, and show run interface E and do show. I need to fix this issue. Actually, they are part of different port channel. But anyways, no problem. Let's go and see. So I can go and check E1/0. I can see protocol is error disabled. You can see some error is coming. E10 is down. Some error disable is there. And here it is duplex. And since we have changed it, so if I go and check E1/2, so here it should be half duplex. So that means if the interface is up, if I go and make these interfaces up, right? So they will, anyways, they will show you, they will throw error. At the moment, this is down because it is error disabled. So let me do one thing. This is not part of the training, but let me go and remove the no. What is the ether channel? Let me do one thing, like E1/0 and default interface E1/0. Maybe it will work. Do show an interface E1/0. Now you can see nothing is there. I have defaulted that. Even I will go here and default interface E1/. I know that these are the back-to-back connectivity, normal connectivity we have in between 110 and 101. And E1/. If I go and check the interface, this is auto duplex. Great. Now it is down. You can see still it is down. So what we can do, interface E1/0, just to shut, no shut, and show interface. Oops, what errors we are receiving now? Okay. Do show interface E1/0 should be up now. Now it is up and full duplex. Now let's go here and check interface E1/2. This is also up. This is full duplex. Full duplex. Now what we will do, E1/2 duplex half. So now it is half duplex, right? And the connected interface is full duplex. So now they may have some issue. So one side is full duplex and one side is half duplex. See, duplex mismatch, right? You're getting this error, duplex mismatch now. So that exactly I want to show you that one side you have different speed, other side you have different speed. So it will go and throw the duplex mismatch. So you should have same type of duplex. So if one side is full, other side also be full, or one side is half, other side also it should be half. Right? And then if you are hard coding the speed, so both sides you hard code the speed or use the speed also as a auto. So if you go to the interface one more time, you can see the auto speed, right? So either you hard code both the sides or you make it auto, right? So for any doubt, any question you have, it's okay, right? So then you have the speed mismatch. You'll understand that you can use these commands to understand that you can check the media type, you can check the speed, and you can go and change the speed to other side. So what are the commands? You can change the speed like the CLI command. You can change the duplex like the CLI command. And you have one command to verify it, right? Show interface and interface name to verify the interfaces. Now, if you want to see only those portions, so you may know that we have the filters as well. So you can go and check show run or maybe show interface E1/2 and then include only what you want to see. Speed is speed or duplex. You can see only speed or duplex. You can filter, right? You can use some filters as well. You want to see only CRC. You don't want to check the entire output. You just wanted to see the CRC, or you want to check the input errors. So you can filter this. You want to see the input errors, CRC. You want to see the speed. So you can give the nesting of these filters and you can get those information, right? So like that, we can select the options as well and you can verify that. What actions? You go to the switches and you correct those informations, then it will work fine. Then I have added some more configuration, but at the moment we haven't just studied about IP addresses and use of VLAN. You can see VLANs are there and IP addresses are there. So point being here is this, that if you check the switch, in a switch, you have two different type of connectivity. One connectivity that is going from switch to switch, right? But there is one other connectivity that should go from switch to PC. Suppose if we have PCs connected, suppose I have PC1, PC2, PC3, then one connectivity you should have that will go from here to here, that is your terminating devices. These are your extending devices. You are extending your network from one switch to other switch, but here you are terminating your interfaces. So configuration over these interfaces will be different over these interfaces. Now these interfaces may pass different type of VLANs. We haven't discussed about VLANs, so I'll not go to that portion here. But yeah, what we are doing with these PCs, that these PCs are always part of one VLAN, one broadcast domain. They are not part of multiple broadcast domain because they have one type of IP. They have one IP, one gateway, one type of subnet mask. that we are going to discuss about that in upcoming session. We have to understand about IPv4 address and IPv6 address. So I will explain more about that. So in that we can go and discuss about the final configuration. So here you can see that we have the final configuration to the switches that you want to connect your PC. Go to that interface, switch port mode interface or switch port mode access, switch port access VLAN, whatever VLAN you want to pass, set the speed, set the duplex. And since this is a VLAN that you created to separate the broadcast domain, so you can go to the VLAN and assign some IP address to that particular VLAN, and that's it. And here, if you know this configuration, that's the good thing about the Cisco devices, routers and switches. Same configuration you have to replicate, only the values will get changed. So if you go and see the other switches, you will see that same configuration, but for VLAN the IP is different. For VLAN IP is different, right? But you have same configuration, same configuration. Yeah, we have done that. Okay, so we have completed day number 3. If you have any question, please feel free to ask.